Well, I am genuinely thrilled to have the opportunity to interview my esteemed friend and mentor, Dr. David Freedman, today. As the chair of the Department of Environmental Engineering and Earth Sciences at Clemson University, Dr. Freedman has made significant contributions to our field, including receiving the prestigious Earth Caretaker Award a few years back. And his impact extends far beyond all the accolades that he has, all the papers that he's written, as he has guided countless students while leading groundbreaking research that propels our entire discipline forward. So it's truly an honor to get to talk to you again today, Dr. Freeman, and to spend this time with you. And I just greatly appreciate your willingness to share your insights with me and all the mentoring and help you've given me over the years and with the environmental community as a whole.
Thank you, Dora. I really appreciate the opportunity to share some thoughts with you and look forward to it.
Awesome. Well, the first question I have is you've been teaching engineering courses for a long time and you've taught a variety of courses over the years. So, is there something that you hope a new graduate will take from your course and really implement in a practical application in the field?
Sure, that's a great question. I think looking ahead, what we have to recognize is that students who major in environmental engineering and science these days are facing some really daunting problems, and none are greater than PFAS and microplastics. So I think what I'm looking to do is help train students to be adaptable, to get the kind of skill sets they need to handle these increasingly complex problems. So, for example, a student entering into the workforce now needs to have a variety of capabilities in areas that we weren't even talking about not that long ago. So, although we aspire to train engineers, those engineers have to have skill sets in molecular biology and analytical chemistry that will allow them to tackle these really daunting problems. I think the other thing that I want to see our graduates be conversant in is areas like life cycle assessment, because we have to turn the corner from being reactive to proactive. We're in a situation where we're in this loop where we keep introducing chemicals that are of increasing concern from a toxicological standpoint into the environment, and then we react looking for ways to treat those chemicals. And so I think our students in the future need to have a strong voice at the table advocating for sustainable practices that will break that loop and put us in a position to enjoy the benefits of an advanced society, but without so many environmental consequences.
I think that's wonderful. And I think leaders like you are what's laying the groundwork for these students to have the foundation they need to be able to build and to adapt, as you mentioned, and grow for the future. So I really appreciate all you do.
Thank you.
One of the things that is very popular with a lot of our customers are the carbon 14 rate studies that you do on the bench scale. And so one of the questions that we get, or, some people as they're applying it ask is, what do you think is the most important point to consider for them to do better implementation into the field when they're transitioning what they've learned from these lab studies to more of a field application?
Yeah, another great question. So I think um, uh, to zoom out a second from that question, it's important for us to remember that to this point in time, the United States has spent over $1 trillion in remediation efforts. And with problems like microplastics and PFAS, we're probably going to increase that amount, double it within the next couple of decades. One of the opportunities that people who work in the remediation area have is to figure out ways to manage costs by accelerating the transition from active remediation to monitored natural attenuation. Now, the bar for doing that is appropriately set very, very high. The last thing we want to do is make transitions like that and only to see that contaminant plumes reach drinking water wells or other ways that people get exposed. So we need tools available to practitioners that will allow them to fully assess whether or not a transition to natural attenuation is possible. Uh, in the area of when um, the dominant degradation process at a site is biotic, there's a suite of tools that are available that look no further than microbial insights as a place to get the information on molecular diagnostics that would help us document the occurrence of biotic chlorination. But when it comes to situations that are common with dilute plumes, below a milligram per liter, uh, often we're seeing that abiotic processes are contributing to mass loss within aquifers. But proving that has uh, turned out to be very difficult because oftentimes with these abiotic processes, the products are not discernible from the background. So we've developed this assay that uh, makes use of practices that have been around for decades, and that's to use the carbon-14 labeled version of these compounds that gives us the ability to detect the products at very low concentrations when you can't measure them easily above the background level. So it's my hope that we can deploy this assay at more sites and make it give the consultants a compelling tool to help convince regulators that degradation is occurring. I want to point out on this one that um, in furtherance of that goal, the journal Groundwater Monitoring and Remediation is working on a special issue right now on transition to monitored natural attenuation. And I know that John Wilson has already submitted a manuscript for that issue, which talks about how you can use laboratory determined rate constants to help uh, to help show that decreases along a plume axis in the field can be explained by degradation processes. And we know from at least one study that we did for a client of Microbial Insights that use of information like that, the laboratory determined rate constants, then overlaid against field data, can make for a compelling case for adoption of monitored natural attenuation, resulting in very substantial savings to clients and certainly preserving important resources that can be used elsewhere. So I'm hoping as we move forward on this journey that we can better convince the remediation community that this tool can be used successfully for transitions to M&A.
That's great. And we also, I'm glad you brought that up about groundwater monitoring and remediation, because we are also submitting with Dr. Wilson and ExxonMobil a paper that talks about the benzyl succinate synthase gene and using that in a similar fashion to better understand rates and transition to monitored natural attenuation at sites. So I think there's going to be some great articles that will be good future guidance coming out in that publication.
Yeah, I think it could be hopefully a turning point that will build some momentum towards adopting M&A as a remedy.
Well, it's because of leaders like you and Dr. Wilson that we have great advice and direction for the future. So I appreciate you putting that together and working on that with him.
Thank you.
The other question that I have for you kind of spins off that is, we have a lot of project managers that are coming into the field and a lot more stakeholders that are getting involved and using these tools, like you mentioned, and being more interested in the data that's produced in a holistic approach in site management. Are there certain things that you wish a project manager or a stakeholder knew or better understood so they could apply it?
Well, first of all, I don't want to be too presumptuous here. I've worked with a lot of site managers and stakeholders, and I know the challenges that they face And, as an academic, I don't want to be presumptuous of stepping into their shoes. I would like to think that folks like myself can serve as a resource to site managers and stakeholders, and that really what's needed at this point is for people who work on processes like assays that can be used through MI, that we need to do a better job of educating the project managers and stakeholders about the potential for how the results of our work can be useful to them in making a case. I'd also want to point out that, sometimes it's been my observation that project managers may be hesitant to adopt new ideas like this, only from the standpoint of the reaction is, well, what if the assay shows that that nothing's happening? Well, I always say that more and better information is better than no information. And I've seen cases where work that we've done is actually can help in the adoption of a technical impracticality waiver, a TI waiver. So sometimes knowing that nothing is really happening at a site can be just as important as being able to document that it is occurring at a rate that's meaningful. So hopefully, with videos like this, we can reach out to the project managers and stakeholders and help convince them that it's worth paying attention to the kind of work that we're doing.
And I really value that feedback because I think that's something we recognize is always a fine line to balance and walk, but educating people on new technologies and tools, but also vetting them and making sure they're ready for site applications so they can provide meaningful data. So I appreciate that you're willing to work with us and help us do that vetting process so that we feel confident in what we share and release as a commercial product to these people to utilize.
Absolutely.
Cool. Well, on the horizon, what do you see next as a future advancement? If you have your crystal ball out and you're ready to share some information with us, but what what advancements would be important for us to make environmental remediation even more effective than what we've been doing historically?
Well, as I look back on this journey that many of us have been taking on remediation, I think back to the time when I was a graduate student, first getting involved with reductive dechlorination of chlorinated ethenes, and the excitement that we shared in learning that microbes have the capacity to break carbon-chlorine bonds. It's important for people to remember that something that we now take for granted, that we have tools to document, that we have cultures to facilitate the process, that didn't exist in the 1980s. I can still remember reading the papers that were expounding on the fact that hey, microbes can accomplish this really important reaction. When we move that to 2025, I think we understand at this point that abiotic processes also contribute to degradation, but our understanding of how that process occurs is still lagging. And I think the comfort level that people will have in adopting and relying on those processes, especially for natural attenuation, will be furthered the more fundamental knowledge we have about the process, which minerals are involved, and in particular, which minerals in situ, under what redox conditions, and what's the role of microorganisms in facilitating abiotic processes. I think all of that, as we accumulate better information about the fundamentals of the process, the more comfortable people are going to be with adopting it. So I think, in that context of reflecting back on the process of biological dechlorination, circling back to PFAS, I think we are only scratched the surface at this point at understanding biological reductive defluorination. I think that's going to be a much tougher nut to crack than the biological dechlorination has been, but the payoff could be enormous. If you look now at the physical and chemical processes that are being deployed to control PFAS, they're effective, they work, but the cost is going to be astronomical. And so I think hope springs eternal that we'll be able to find a breakthrough in the biological defluorination, because the rule of thumb that I tell students is that if you can accomplish a task with microbes, the cost of doing so is likely to be way lower than it is using a physical or chemical process. So let's hope that when we turn the page 10 years from now, that we'll have made some breakthroughs in that area.
I hope so. And I think with the research that you and others are doing, that's definitely a possibility. We've learned a lot more than we knew even 6 months ago. It feels like it's a lot of advancement happening quickly.
Yep.
So, we talked a little bit about microbial insights and recommendations for education and things that we can do. Can you give me some advice or some thoughts that you have about, what's the most important impact that you see that we can make on the environmental community?
Well, first of all, the impacts that Microbial Insights already has made are, I can't understate how significant they are. A couple of decades ago, when we were learning the process of biological reductive dechlorination, the tools that people were developing to document the process were all pretty much restricted to academic labs. They're expensive, took a long time to get results. And now it's just absolutely amazing that your clients can send in samples and have really meaningful results at very reasonable costs in a short amount of time. That's so critical to helping figure out what's happening at a site, whether that's in the area of reductive dechlorination or petroleum hydrocarbons, corrosion. So I think kudos to you on the company that you've built that's been able to tackle these problems. And I have to say that it's been just a delight to me to be able to work with MI. I know that when we started thinking about doing the C14 assay to the broader community, I knew it would be important to partner with somebody who had a reputation with their clients that would give them a comfort level that, yeah, if we're working with MI, we know that the product's going to be quality. And so that's been really a great journey for me to work with you folks on doing that. And I think when you zoom out a little bit on that, the thing I'll encourage you to keep doing is your openness to adopting new types of testing platforms. You've been a leader in areas like biotraps. You recently adopted the min traps, and we're just at the doorstep with the C14 work. So I think all I can say is keep having an open mind. Again, kudos to you for staying so current on the field and being aware of where the opportunities are and how those opportunities can translate into practical, economical testing that the remediation community can use.
Well, thank you so much. That means the world to me. And it's really through mentorship with people like you, Dr. Wilson, Frank Loeffler, that have given us the academic background and information that we need to be able to offer these on a commercial basis. So without you, it wouldn't be possible. So I'm very grateful for your help and your contributions over the years.
It's been a pleasure. I think it's a credit from the top down that the folks at Microbial Insights have uniformly had a great experience dealing with your employees. And I just know among my colleagues that MI has a fantastic reputation. And like I say, that starts with the top.
Thank you so much. That really touches me and means so much. And I'm so grateful for you. Before we end today, is there a story that you'd like to share with us from the industry, or a memory, or anything else that you'd like to add that you think would be valuable?
Uh, I'd just like to say that one other way that I have found kind of satisfaction in the field in both the professional sense, but also the personal sense, is the gatherings that MI has sponsored at meetings. Uh, you know, it's fun working together on the technical stuff, but those kind of gatherings offer an opportunity for people to let their guard down and chew the fat on what we all have been working on and get to know one another personally. So that's something I've valued over the years, and I hope we keep doing it.
Oh, we'll have to do that at Battelle if you're going to be in Boston with us this year. So
Absolutely. Yeah. Yeah.
well, thank you again, Dr. Freeman. I appreciate it. You're such a leader in the field, and it's an honor to know you and to get to talk to you. And it's an honor to call you my friend. I'm glad we have that personal time together. And so I'm just grateful for you for today and for sharing with our industry and for all the hard work that you do, and especially for all the work that you do for your students. They're very blessed to have you and the involvement that you provide.
Thanks, Dora. I really appreciate that.